Hey guys, so here's the note for 7.6 day 1. We're going to be solving exponential equations. Okay, so there's going to be two different ways of doing this. The first way is getting the bases the same. So we are able to think about them exponentially wise and get them to be the same. We're going to do that, and then we'll be able to set the exponents equal to each other and then solve for the variable, okay? So let's look at those type of problems. So number 1, we have 3 to the 3x minus 2 equals 3 to the x plus 1 power. Okay, notice that the bases are exactly the same here. So since the bases are the same, we just set the exponents equal to each other. And solve. So I'm going to take my 3x minus 2 equal to x plus 1. Okay, now we just basically solve. So I'll just subtract x to the other side, so I get 2x minus 2 equals 1. Add 2 to the other side, so I get 2x equals 3. And then I get x equals 3/2. Here we go. Now, I could plug this 3/2 back into my original problem, just to check to make sure that I did this correctly. So let's go ahead and do that. So I have 3, and then it's 3 times 3/2 minus 2 equals 3 to the 3/2 plus 1. Okay. So I'm plugging it back, my x, into wherever I see x in my original equation. And I'm just checking to make sure I did this correctly. Okay, so 3 times 3/2 gives me 9/2 minus 2 equals 3. 3/2 plus 1, that'll give me 5/2. And then I get, and you can plug this also in your calculator, so I get 3 equals 5/2, which equals 3 equals 5/2. And we know that's going to be the same. So it works out. X equals 3/2. I did this correctly. I got the right answer. Okay. Now, you don't always have to check your answer, but that's just a way if you're like, I'm not sure if I did this correctly. You can always take your x value and plug it back just into the original equation for wherever you see x. Okay, let's look at number 2. We have 9 to the 2x equals 27 to the x minus 1 power. Now here, we can see that the bases are not exactly the same. But maybe there is a number that 9 and 27 have in common exponentially wise. Well, what is maybe a number that we can change this into and think of it as an exponent? Well, what about 3? So meaning, if I do 3 to a power gives me 9. Well, that's going to be 3 squared. So all I'm doing is I'm rewriting the 9 as 3 squared. It's just writing something different, but it's equivalent, right? Now, don't forget, we still have this 2x as a power, so I'm going to take my 2 and multiply by the 2x. So I'm going to do the same thing here. 3 to a power gives me 27. It's going to be the 3. And then I have my x minus 1. So those exponents do have to stay there, okay? So x minus 1 doesn't magically disappear. It needs to be there. So all I'm doing is just rewriting my base to the exponent, so the bases are exactly the same, okay? Okay, so now, since my bases are the same, I can set what's in the exponents equal to each other. So 2 times 2x gives me 4x, and then I need to distribute the 3 to both the x and the minus 1. So now I just move the 3x over by subtracting, so I get x equals negative 3, and there's my final answer. And as I said before, you can plug that negative 3 back into the original equation, so it would be the 9 times 2, or 9 to the second power, times negative 3 equals 27 to the negative 3 minus 1 power. So let's just check this to make sure we did this correctly. So I get 9 to the negative 6 equals 27 to the negative 4. Now you might be wondering, but I don't know because the bases aren't the same here. Well, let's just use our calculator. So let's say I do 9 to the negative 6. Let's just see if we get the same number. And then let's do 27. So 27 to the negative 4th. Yep. I get exactly the same number, so that means x equals -3. That is the correct answer. Okay, let's try a few more of these. Okay, I want you guys to go ahead and pause the video and try number 3 here. Okay, let's see what you got. So 4 and 1/2. So we can definitely tell these bases are not the same, but we can probably think of a number that 4 and 1/2 have in common exponentially wise. Now, sometimes on these problems, you might use a different base than someone else and still get the same answer. That is true because some of these problems might have different bases they have in common, but you'll get that same answer. So like with this one, maybe some of you use the base of 4. Maybe some of you use the base of 2. Or some of you might have used the base of 1/2. It just depends, okay? I'm going to go ahead because I like to keep it, let's do the base of 2 here, okay? So I'm going to do 2 and then equals 2. Okay, so remember, we can't just magically change these numbers into 2. We have to write an equivalency. So now 2 to what power gives me that 4? That's going to be squared. So 2 squared is the same thing as saying 4. Now on that 4, there was an x exponent, so I do need to keep that. Now, 2 to the 1/2. Notice I went from a whole number to a fraction. So what happens with that? Is our exponent positive or negative? It is negative. Now, because in the 1/2, the denominator, that value is the same as our base here, we're going to have -1 power. So you can also just do 2 to the negative first. Does that give you 1/2? Yes. And then I keep my exponent. There we go. So you can also plug this into your calculator to make sure if you get the correct numbers. Okay, now my bases are the same. I just set the exponents equal to each other. I do need to distribute that -1, so I get -x plus 3. I'm going to go ahead and add x to the other side, so I get 3x equals 3, and divide both sides by 3, so I get 1. And as I said before, you can plug that back into our original equation to check. Might as well do it. So I have 4 to the first equals 1/2. What was it? Was it x minus 3? 1 to the -3rd. So I get 4 equals 1/2 to the -2nd. Well, we can plug 1/2 to the -2nd into our calculator and see, does that give us 4? So I have 1 divided by 2 to the -2nd. Yes. So we did this correctly, and we got the right answer. Okay, this number 4 is exactly the same as we did before, so don't worry about that. Okay, make sure you guys watch. Actually, I want to do another one that's not on here. Let me change this one. We are actually going to do a number 4. We're going to do this. So 6 to the 2x plus 4 equals 36 to the 3x plus 1. So now I want you guys to pause the video again and try this one on your own. Okay, let's see what you got. So I'm going to keep my base as probably 6, because I think that's going to be the easiest thing, because 6 and 36, they have 6 in common. So because I'm keeping this base exactly the same, nothing changes. But I'm making this 6. Now 6 to what power gives me my 36? That's going to be squared. So another way of saying 36 is 6 squared. And then 3x plus 1. Now that my bases are the same, I'm going to set the exponents equal to each other and solve. And don't forget, I need to distribute the 2 to the 3x and 1, so I get 6x plus 2. Okay, I'm going to subtract 2x from both sides. And then I'm going to subtract 2 from both sides. And divide by 4. So I get 1/2 as my answer. And as I said before, you can always plug that back into the original equation to check if your answer is correct. Okay, make sure you watch the next part of our video. That's where we're going to be talking about, well, what happens when we can't get our bases to be the same.